Hi, welcome. I'm just going to go ahead and get started since some people are here. And then as people come in, they can join. And I'm also going to be posting this video as well. So I'm going to start by sharing a PowerPoint for the section that we're covering this week. And then my plan is to work on some practice problems. But if you have any homework problems that you've already started that you have questions about, then we can also work on those as well. So as I'm going through this, I'll be presenting some information, then I'll be asking you questions. You're welcome to either type an answer into the chat or turn yourself off mute and give me an answer if you'd like. And then after we get through the PowerPoint, then we can also see if there's any questions that y'all have specifically about the homework. And thanks for coming. I wasn't really sure what kind of turnout to expect because this is new for me this semester. So happy to be here. All right, I'm going to start sharing my screen here. And here it is. This is the one that I want to share. So hopefully you all can see my screen. Let me put it into a slideshow. There we go. Okay, so our main topic is going to be estimation, graphs, and then mathematical models. And let's go ahead and do this way, okay? So in math, it's really important to pay attention to definitions. So anytime there's a definition, those are really good things to kind of write down, make sure you have handy when you're doing your work. And kind of start making a list of things that you're going to want to include in your notes when you take your exam, because you're allowed 2 or 3 pages of notes. So it's never too early to kind of start thinking about what you're going to want to put in there. So estimation is just a way of giving ourselves an approximate answer. And many times we think we have an exact answer, but we really have an approximation. And so one way we can estimate is by rounding numbers. We do this all the time. You know, if something costs $10.99 in my head, I automatically think that's $11, right? So I just rounded that to the nearest dollar. We're also going to look at using graphs and how we can estimate things by looking at a graph, and then mathematical models. So think an estimation is an approximate answer. One of the ways I find this really useful when I'm doing math problems myself is to think about, is my answer, after I did all these calculations, is my answer in the ballpark? And so estimations are really good for that as well. So the first thing we're going to look at is rounding whole numbers, okay? And when you're thinking about rounding, and hold on, let me come over here and get my pen to work. Here we go. When you're thinking about rounding, you want to think about your decimal places, okay? So a whole number doesn't have anything, if you think about that decimal point here, so we could have digits to the right and then more digits to the left. So this isn't a whole number because I've got digits over to the right. So if I'm rounding a whole number, I'm looking at these digits over here and I'm not going to have anything to the right. And what I do is I just look to the right of that number. So if I have the number 1,532 and I want to round this to the nearest tens, okay? These are the tens place. So I'm going to look to the digit just to the right of that, which in this case is a 2. Because it's a 2, I'm going to leave it alone, okay? If it's less than 5, I leave it alone. If it's 5 or greater, I'm going to increase it, but it's less than 5. So I'm going to leave it alone, and then I'm going to get rid of this digit over here and make it a 0. So 1,532 becomes 1,530 if I round to the nearest tens place. So to really understand this, we want to understand what all our decimal places are. So let's talk about that for a minute here. So I'm just going to write a large number. Whoops. Hold on. I didn't want to do that. Let's see. There we go. Okay. All right. So this is the ones place. As we move over, this is the tens, the hundreds. These are thousands. These are 1,000s, 10,000s, 100,000s. And when we move into this triplet here, we've got millions, 1 million, tens of millions, hundreds of millions. Over here, we've got billions. And if I keep going, that brings me to trillions and so forth. So these are all whole numbers. On this side, we've got fractions. So 1/10ths, hundredths, thousandths, and million, 10,000ths. And so notice that these have on the end, right? So these are tenths, whereas these are tens. Okay. So to the right are fractional parts. Okay. And there we go. All right. Now I'm going to look at my next screen. Maybe. Nope. Hold on. This doesn't want to work. Oh, I know what I need to do. There we go. All right. So if I want to round, this is an example of maybe what the world population might be. If I want to round this to the nearest 100 million, what I first have to do is find the 100 millions place. So as we said, these are ones, tens, hundreds. These are all thousands, and these are all millions. These are 1 millions, 10 millions, 100 millions. So this is the place that I want to round. I look to the right and I see a 4, which means I'm going to leave the 8 alone. 0 through 4, I leave it alone. 5 through 9, I increase it. It's 0 through 4, so I'm going to leave the 8 and 8, and then all these other digits turn into zeros. So that's what that number looks like if I round it to the nearest 100 million. Questions? Who feels like they already knew this? Let's move on. Anybody? No? Okay. Let's do another example then. Okay. Oh, did I go too far? Yeah, I did go too far. Okay, what if I want to round it to the nearest million? Now I got to find the millions place. So these are the millions, right? The 4 is in the 10 millions and the 8 is the 100 millions. These are the million place. Again, I look to the right. That's a 1. That's in the 0 through 4 range. So I'm going to erase all of these digits and replace them with 0, and I'm going to leave the 3 alone. And then finally, I think we have one. There we go. To the nearest 100,000. Okay. So remember, these are the thousands and these are the ones, tens, 100,000s. That's this place here. Now this time when I look to the digit to the right, that's between 5 and 9. So that means I'm going to increase the 1, make it a 2, and then all the other digits become zeros. And kind of another way of thinking about this that I found useful when I was first learning this, let's look at an example of rounding 153 just to the nearest 100. What you're really asking yourself is it closer to 100 or 200? Yeah. So that's really kind of why we're doing this technique here. So I think understanding this is helpful as well. All righty. Now we're going to take a look at doing this same process, but with decimals. Okay. All right. So we have here an approximation for the number pi, 3.141592. Those are the first 7 digits of pi. And if we want to round this to the nearest hundredth, So remember this place here, these are tenths. Then these are hundredths. These are thousandths, and so forth. So to round to the nearest hundredth, I find that hundredths place, which is right here. 4 hundredths. Same process. I just look to the right. Over here to the right of the 4, I have a 1. That's in the 0 through 4 range. So I'm going to leave the 4 alone. But this time, instead of writing a bunch of zeros, we just stop there. Okay. We don't need to write the zeros because it's equivalent. So 3.14, that's usually the number that we use for pi, isn't it? Questions so far? No? So far, so good? Okay.
So like when it's on the side of the decimal point, like they go by like fractions, like
Yes.
1/10, and then 1/100th, one, is it 1,000? 1/1,000?
Yes.
Or
So
one,
this
and then one,
next, yes. So these are tenths.
mm,
These are
that's
hundreds.
hundreds.
These are
That's
thousandths.
thousands.
These are 10,000ths.
And that's a hundred
You just
thousand.
keep adding a zero,
Okay.
100,000ths.
Okay.
These are millionths. Yeah. Uh-huh. So to round pi to the nearest thousandth, that's this. Whoops, I went too big. Let me try that again. Whoops. Okay, that's this digit, right? Tenths, hundredths, thousandths. Oh, another way, Rachel, to think about this is if you count how many places over you go. So this digit is 3 to the right, yeah? So you can think of there's going to be 3 zeros. So these are thousandths. Yeah. The 2 is 1, 2, 3, 4, 5, 6 places to the right. So these are a 1 with 6 zeros, millionths.
Yeah, that
Yeah.
makes sense.
Yeah, that helps me to remember those.
Hmm.
Okay, so rounding to the nearest thousandth, that's this digit. So I look to the right, that is 5 or greater. That means I'm going to change the 1 to a 2.
Hmm.
So I'm going to round it to 3.142. And we don't include those extra zeros. Like we need the zeros with the whole numbers, right? Because
Yeah.
they're actually holding a place. We don't need them with the decimals.
Mhm.
Okay, let's see what else we got here. Come on. There we go. Okay. So this is one way where rounding is really useful. Uh, in fact, when back in the days when I was not bringing in a lot of income, I had 3 children at home. And, every time I went to the grocery store, I had a certain amount of money to spend. I would actually, in my head, every time I put something in the cart, I would round and add it in. So I knew that when I got to the front of the store, I had the money. So this is a really useful way of using rounding. So, for example, I'm at the grocery store and bread is $2.59. Then, I wasn't going to add up all these numbers. Whoops. I wasn't going to add up all the numbers exactly because I didn't want to work that hard, but I could round them really easily. So here I'm just rounding to the nearest dollar. So I'm just looking at what's here in the 10-cent column. And so there's a 5, so I round that up to 3. This one has a 1, so I leave this a 5 and call it $5. This one I have a 6 over here, so I'm going to say that's closer to $4. This apple is closer to 0. And then the coffee is closer to 9. Now it's really easy to add up 3, 5, 4, 9. So that I can do pretty easily in my head. 3 and 5 is 8. 8 and 4 is 12. And then 12 and 9 is $21. So I know that when I get up to the front, I better have, or in this day and age now, I better have $21 in whatever account that I'm electronically paying with, right? So the question though was the total bill was $24.67. Oh, I do this all the time too when I'm shopping because they make so many mistakes, right? So if I got my receipt back and the receipt said that I owed $50, I'd be like, wait a minute, you added something up wrong. So it's also really useful. This is one of the things my mama taught me when I was a little girl. You always make sure you don't get overcharged. And so this is one way to really, without having to do all the adding, you know? So $21, 24.67 seems reasonable then, right? There might have been a little tax added in, for example. What questions do we have about that one?
If the apple was like 50 cents, would that be closer to zero or a dollar?
We would round it up to a
A
dollar.
dollar. Okay.
Yep, 5 or greater, we go up.
Hmm.
0 through 4, we leave it alone. Good
Okay.
question. And actually, if it, you know, it's a different way of estimating, but if I really am concerned about, you know, if I have enough cash, I would round them all up. That way, you know, that way I know I'm not going to go over. But for if I'm just checking whether my bill is right, I like this way. Okay, whoops, I went too far again. Okay, so circle graphs. Okay, you've probably seen these. They're used all over the place in print, and it's just a quick way to kind of show if I have a large group and I want to categorize members of the group, how many fall into the various categories or what we're calling pieces or even sectors. We also sometimes call it a pie chart because it looks like slices of a pie. So here we have how Americans define old age. So you can see pretty quickly, most people define old age as being a time of decline in mental functioning or a decline in physical ability. And then we have a few people, you know, maybe it's a certain age. You know, when you're 20, it's maybe 30. And then if you're 80, it might be 100. I don't know. Retirement, becoming a grandparent. So we have all these different ways. And then these circle graphs are really just a nice way to kind of get an idea of what the majority is doing. But if I have something like this, so say I saw this in print somewhere or online somewhere, and then I knew that at the time that the last Census Bureau was taken, there were 249,019,818 Americans that were 25 or older. And let's say that this is representing their opinions on old age. And if I wanted to get an idea of about how many people associated old age with a decline in mental functioning, then I could, instead of having to do an exact calculation, I could do a little rounding. Okay, so I want to estimate here about what number of Americans define old age by decline in physical ability. Okay, so that's this one. So what I'm going to do is I'm going to round this number and this number. And I have lots of choices, you know, rounding this to the nearest 100 doesn't help me out a lot. Rounding it to the nearest 100 millions is going to be kind of a big jump. So what I'm going to do is I'm going to choose this place here. Okay. I'm going to round it to the nearest 10 millions. So if I'm rounding that, because I have a 9 to the right, I'm going to make that 250 million. So I'm saying there's about 250 million Americans 25 or older. And then I'm going to also round this number. So instead of multiplying by 41%, I'm going to say, well, that's practically 40%, right? Because if I round that to the nearest tens, I get 40%. And then do you remember that 40% is equivalent to 0.4, right? When you want to convert a decimal, make that a percent. When I'm converting the percent to the decimal, I think move the decimal point 1, 2 to the left. So 40% is equivalent to 0.40. Now I've got a really easy either calculator or mental math problem. This one is actually not bad mental math because I can just think about multiplying 4 times 25. And that's just like 4 quarters, right? 4 quarters is $1. So 4 times 25 is 100. And then I've got an extra 1, 2, 3, 4, 5, 6, 7 zeros here. But then this decimal point is going to remove a 0. So I'm going to add in an extra 6 zeros. So that means about 100 million. And that makes sense, right? Because I said there were 250 million in all. So it makes sense that 40% is about 100 million. So about 100 million people in the US who are 25 or older would say old age is basically a decline in physical ability. What do you guys think about that one?
Like when you round the like the 249 million, is it just like a common like rule to round it at the 10 millionth place? Or is that the 10 millionth place? What
Yeah,
was it again?
I could have also done the 1 millions.
Hmm.
It actually would have, yeah, it would have been 249. I just wanted to make it really easy.
Okay.
So, in something like this, I'm kind of thinking about, I think about not so much accuracy, but what's going to be an easy calculation to do in my head.
Hmm.
Mhm. And then because this is kind of right, because 250 is right in between 2 and 3, I wouldn't really want to round it up to the 100 millions. It would just be a lot less accurate. Okay, whoops. You know what? I'm seeing some chat. Let me check the chat. Oh, this says I can't hear the instructor.
That
Okay.
was me earlier, but I figured it out.
I'm so sorry. Yeah, I have some new equipment here that I'm getting used to, so I forgot to open up the chat. So sorry.
No, you're fine.
Okay, so I'm glad you figured it out. Okay, bar graphs. So a bar graph is just another way of representing data. Again, we use it when we have categories, and what I like about the pie chart or the circle graph is that you can kind of see the parts in the whole and how they fit in. A bar graph is more a way of kind of comparing categories one to another without really so much looking at the big picture. And if I have two types of categories, then I can do what we call here a side-by-side bar graph. And what we have here is life expectancy in the US starting with the year 1950. So in 1950, males had a life expectancy of 65.6. That's why they used to retire at age 65. We were never meant to retire and take 30 years off. That it was kind of like, you're done. You get half a year. Females was 71.1. And then now it's quite a lot higher, isn't it? 77.1 for men and 81.9 for women. I think it's a combination of things. I think we're better. Oh, somebody has their hand up. Yes. Is it Danny? Yeah, go ahead.
Um, so I'm sorry. So I'm watching it at work. So I was doing it on my break. So I'll be back in, but I'll be
Okay.
watching it. Is that okay if I don't have my camera on?
Yeah, don't worry about it.
Okay.
And I'll also post a recording of this to my YouTube channel. And
Okay.
if you're, it should have been, that channel should have been posted in your announcements, no matter what class you're in.
Yeah, I
And-
seen it.
Yeah,
Yeah.
okay. All
Okay.
right. But you can
So I'll
always
be back
email
in,
me.
but I'll be watching it, but
Yeah,
just my camera's
no
not on.
worries. Yeah, don't worry about it.
Okay.
Okay. So so back to this particular problem. So we can see there's been kind of a steady increase. And then we might have a question like, if I can get my equipment to work, there we go. Okay. We might want to estimate about how much has the male's life expectancy increased for each subsequent birth year. So in other words, from 1950, when we had an average age of 65.6 to 2020, when we had an average age of 77.1. About how much has the life expectancy gone up? So per year, okay? So I'm first going to ask myself, well, how many years has that been? So from 1950 to 2000 would be 50 years. And then from 2000 to 2020 would be 20 years. So that's 70 years we're talking about here. And then I'm probably just going to round this one. So 65.6, I'm going to round to 66. Just rounding up to the nearest whole number. Again, this number's bigger than 4, so I'm going to round up. And then 77.1, I'm going to round to 77. And so the difference there is, let's see, 4 plus 7, so 11 years. Okay. So estimated males increased life expectancy for each subsequent. So the life expectancy increased 11 years and the time frame was 70 years. So over 70 years, we went up about 11 over 70 per year. Okay. So that's the increased life expectancy per year. And let's see if they want us to do, oops. Okay, so they are doing an approximation using a calculator. So let's take a look at that. This is a good time now. Let's see. And what I'm going to do for a minute here is pop out of this. And then I'm going to have to stop the share and do a new share so that you can see. Okay. So the calculator, of course, you can use a hand calculator, but I also really like Desmos. Have you all seen Desmos before? Okay. You can see my screen now? Okay. So I just type in desmos.com, and I like to use the graphing calculator because it's more powerful. So I do desmos.com/graphing. Okay. And I get this beautiful calculator. I can graph things. There's lots of functions, and we'll be using it throughout the semester. But for this one, I just want to approximate, what did I have? I had 11 out of 70. So I can just type in 11 over 70. And it does that quick calculation for me. And then they wanted me to round to the nearest hundredth. So that means I'm going to take a look right here. And the 1 is in the tenths, the 5 is in the hundredths. So I look to the right and I see a 7. So I'm going to round this up to 0.16. So if I round to the nearest hundredth for each year between 1950 and 2020, the male life expectancy went up by 0.16 of a year. That's pretty good. I made some nice advances in medicine. Oh, and this is a cute little, is this the right one? Yeah, this is a cute little thing too. So when you're doing calculations, this little number that you have here, okay, it's not as, it doesn't show it as much here. Let me think about what would show this better. Oh, so I have, say I have a decimal and I want to convert it to a fraction. Look at this. That's pretty cute, isn't it? Decimal fraction. So it toggles for me. That's another nice little feature of Desmos. We'll be learning more kind of throughout the semester. Okay, let's go back to our slideshow. Here we go. Okay. So you can see the slideshow again now? Or no? Yeah? Okay. All righty. So we did that one. Okay. Oh, and now this is where this gets really powerful. So we said that for each year after 1950, male life expectancy went up by about 0.16 years. So if I want to estimate about what the life expectancy would be for a male born in 2030, well, I know that for each year after 1950, I need to add 0.16. So in 1950, the life expectancy was 65.6, whoops, as we see here. And then I'm going to say from 1950 to 2030, that's an increase of 80 years. So I'm going to multiply that 0.16 times 80, and I get 12.8. So I would expect a male born in 2030 to have a life expectancy of 78.4. So this is a way that we can use our graph to estimate things based on what we're reading. What questions do we have about that one?
I think I just did the like orders of operations wrong. Like,
Oh,
so I'm supposed to, if it's a decimal, I have to do multiplication first. And then, yeah,
yes, that's
at
right.
PEMDAS, right? It's PEMDAS?
Yes, that's right.
Okay.
The multiplication comes first. Yes. Good. Yeah. So you do first the 0.16 times 80, then you add the 65.6. Or if you type this line into Desmos, whoops, it would do it for you. It knows the correct order of operations. Sometimes we have to give it parentheses depending on what we're doing, but for this one, it would do it correctly. Okay, another type of graph that we have is a line graph. And typically we use line graphs when we have two types of information that we're comparing. One really common use would be showing something changing over time. So on my horizontal axis, I would usually plot units of time. And then on my vertical axis, I would plot whatever it is that I'm measuring. So here we have cigarette use by US college students. So you can see in 1982, it was pretty high. It started going down, went back up again in 1998, and then it's been declining. They're just doing other things, aren't they? Now they're vaping. Okay, so first question, find an estimate for the percentage of college students who smoked in 2010. So we're literally just kind of reading the graph here. Let me get my pen back up again. There we go. Okay, so 2010, this is 2006, this is 2004. So halfway between would be 2010. So this is the year 2010. And then if I want to estimate, I kind of have to think about going over to here where that line hits on this axis. So looks like maybe 17, I didn't draw that line perfectly straight, but maybe 17%, 18%, I'm gonna call it 18%. We're estimating, right? So we don't have to get it exactly right. But so that would be an estimate for the number of smokers in 2010. Oh, what else do we have? In what year, in what 4-year period? Oh, this is an interesting question. Whoops. So in what 4-year period did the percentage decrease at the greatest rate? So a decrease from one year to the next would be represented by the graph going down to the right. Okay, so you can see, keep losing my pen, hold on. So you can see here we're decreasing from here to here, and then we're increasing, decreasing. And we want, these are all 4-year periods, aren't they? 82 to 86, 86 to 90, and so forth. So what I'm really looking for is what's the steepest decline, right? So this would be a little bit of a decrease, and this would be a lot of a decrease. So the sharper that drop is. And it looks to me like we have the sharpest drop from here. So that would be between 2002 and 2006. We have the greatest decrease. Where does it look like we have the greatest increase? Anybody?
Would it be oh shoot, I don't know, to the 1998, and I can't see.
Yeah, I think it'd be, so this one here, this is 8 years from here to here. So it's
Okay.
years, so 94.
Okay.
Yeah, 94 to 98 looks like it has the greatest. Yep, I agree. Good, thank you. Okay, oh, what year did 30% of college students smoke? So for that one, it just looks like 30 would be right here between 28 and 32. So if we come across to here, it looks like 1998, 38% or 30% were smoking. Okay. Oh, I think this is, yeah, that was where I wanted to stop because I wanted to make sure we have time if anybody has any questions, and I wanted to do some other examples. So let me stop this share and ask, does anybody have anything that they want to see, problems from the homework or anything like that that you wanted to look at?
I don't think I have any.
Okay. So then the other thing that I wanted to show you, so we have all of these assignments. Whoops, I forgot to share. We have these assignments, homeworks and quizzes and things like that. And then there are also additional practice problems that you might find helpful in preparing for exams and things like that, or just if you want extra problems. I also really recommend at least looking through the book and looking at anything bolded is probably a term that might be useful to know. Anything boxed is also could be a term or a formula or something like that. Why is it still doing that? Oh, I know what I did. Sorry. End slideshow. That's what I wanted to do. Okay, back to our book here. Okay, so here's the book. When you open up, do you guys know how to get to the book?
Do we just like click on a link that's possibly?
Yeah, so in your modules, here it is. Right at the very top of your modules, you've got course textbook. So you click on course textbook, and then it's going to open up Vital Source for you. And if you have other books from other classes, you'll see them, but ours is called Thinking Mathematically. This little guide lets you toggle between seeing the table of contents and not. It's useful to look at the table of contents if you're just trying to get to, for example, this week, we're looking at chapter 1.2. So I can go to 1.2, click on it, and it brings up the chapter. The other thing that's useful here is that at the end of each section, so I'm to get to the end of that one, I can jump ahead to 1.3, and then I can just go back a little bit. So at the end of each section are some sample problems, which are really helpful. And the other nice thing about these sample problems is that all of the odd numbers have answers in the textbook at the back of the book. So it's a good way to do some extra practice without like wondering, did I do it right? You can actually go and see whether you did it right. So to get those answers, you just scroll down in the bottom of your table of contents here where it says answer to selected exercises. And then you can see, here's all the end. You can scroll through and see all of the answers section by section. Once I get to where I want, I click on this little circle here to get rid of the table of contents so that I have a nicer view of whatever I'm looking at. So I wanted to look at a few of these problems that I think are helpful and are similar to some things that you're going to see. Whoops, let's go backwards again because it's easier to get there. So similar to what you're going to see in the homeworks. Okay. Oh, I like problem C6. That's a good one to start with. Okay, what did we have here? True. Oh, so some of the questions that you'll see in the homework and quizzes and such are these kind of true, false, or multiple choice that are not computing anything, but just like thinking about definitions and things. So what do you guys think about this one? Mathematical modeling results in formulas that give exact values of real world phenomena over time.
I
True,
think
false.
Is
it's
it
probably wrong,
false?
but I think false.
It's what is the word that makes you go, that might be a little bit of an overstatement. What's the word
The
that's
exact.
Exact.
yes, right? It gives us estimates. Yes, very
Mhm.
good. All right, you guys got that one. So that's what, on those types of questions, that's what you're looking for. Like, and a lot of times there'll be multiple choice. So you'll see, yes, it's true because, or no, it's not true because. So always read those because parts. That's going to help you figure out
Mhm.
whether it is true or not, as well
Yeah.
as what the right answer is. Okay, and then we have some practice here. Here's a good one. So this is another number, kind of like pi, that you maybe have seen in other math classes, but it's a very important number in mathematics. And we give it a name E because it's like pi, it goes on endlessly. There's an infinite number of decimals. So this is another one that's good for practicing rounding. So let's all try practice rounding this to the nearest 10,000th. And then when you think you have an answer, type it into the chat. What would that be rounded to the nearest 10,000th?
Wait, I don't know if I'm right.
Okay, we want to the nearest 10,000th. So let me bring
Or
up my,
seven the thousand. Oh, we're doing number 4.
whoops. I just did, can you still see my screen?
Yeah, we can see you.
You can see, yeah,
Oh,
I
no,
think
that's a
I,
textbook.
yes, I accidentally got it out of share. Hold on, let me bring it back up again. Too many things going on here. Okay. What I wanted to do, where did my tool go? Oh, share. There we go. Okay. Okay. Got my tool now. Okay, so what decimal place is this?
The
That's the
110.
thousandths.
The 7 is the tenths, right?
Mhm.
Oh, okay.
These are hundredths,
And then the 8 is 1,000.
thousandths, and we want 10,000ths. That's right here.
Oh.
Oh. So
Yeah.
seven's the wait, seven's the thousandths? Or no, it's
No,
the
7
tenth.
is the tenths. Let me
Okay.
see if they might have, hold on one second before we finish that question. Let me just, I think we have a really nice picture of that in here somewhere in the textbook. And if not, I'll just pull one up. Here we go. Oh,
Mm.
this is not what I wanted, but this
Uh-oh.
will do. Okay. Okay. So These are the ones, and then
Yeah.
we get bigger tens and so forth. And then in this direction, each time we add another zero to the denominator. So tenths,
Mhm.
hundredths, thousandths, 10,000ths, and so forth.
Okay.
And I think there, let me go back one more page. I think they might, I thought they had the whole. Wanted like a whole, but that's okay. So this page here shows us the whole numbers. So 1, 10, 100, and so forth. And then this other page, the next page shows us the fractional parts. So ones, tenths, hundredths. And again, remember, you can figure out which place it is. So for example, if you think about this place here, it's 1, 2, 3, 4, 5 to the right of the decimal. That means these are a 1 with 5 zeros, 100,000ths.
Right.
Yeah. Okay, so back to our, let's see, I think that was probably on about page, whoops. See if I can jump ahead a little bit. I think maybe page 21-ish. No. Oops, back one more. Okay, so here's our beautiful number. We have one around to the nearest 100. What were we doing? The nearest 100,000. Is that what we said? 10, no, we said 10,000. Let's do
Okay.
the 10,000th. Okay, so 10,000 would be this number. Yeah.
Yes.
So I want the fourth digit after the decimal place. That's here.
Okay.
So then I got to look to the right to see whether I'm going to round up or leave it alone.
You'd round up.
Yes. So what does that give me?
It'd be 2.7183.
That's it. Yes.
Okay.
Beautiful. To the nearest 10,000th. So you'll have several questions like that in the homework. What do we think? We're ready to go on those?
Yes. I think I just
Oh.
need to like look over it more.
Yeah.
Like get it in my head.
And even like make yourself a little drawing of that picture that I
Yeah.
showed you in the book. Or I'm sure if you Google like decimal places, you'll come up with
Yeah.
a nice graphic that you could use that would be helpful for that.
Mhm.
And remember, homework, you can do those multiple times.
Okay.
So if you do the homework and you miss a few and you're like, let's go for 100,
Mhm.
might as well.
Yeah.
Okay, what else? Oh, so sometimes it'll just say to a certain number of decimal places. So like number 7 to 9 decimal places, then I just count what's the 9th spot after the 0. Or I'm sorry, after the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8. This is in the 9th spot. So I'm just going to copy down all the way almost until I get to there. And then what am I going to do?
Round, just keep it the same.
Yep. And now I have 9 decimal places. Yep, that's it.
Okay.
A little bit easier when it just asks you for a
Yeah.
place. Clear that and see what else I have. Number 14. Let's see. Oh, and I got to move this over to here. Move this over to here. What are we doing here? Okay, so and notice on these it says estimate and then use your calculator to actually perform it and compare the difference. Okay.
Yeah.
Some people make the mistake when it says to estimate, they do the calculation and then they round. But the whole point of estimating is that you're going to round, come up with easier numbers to do arithmetic on, then do the arithmetic, and then leave your answer. So which one did I want to do? 14. So 46.13 minus 15.237. So for that one, I might just round it to, it doesn't say, so I'm going to round it to the nearest whole number because that'll make it easier.
Mhm.
So what do I round this to?
46, right?
Yep, 46. And I round this to,
That's just 15.
yeah, so I'm just going to do 46 minus 15 and I get anybody?
31. Right?
31. Yep.
Okay.
Mhm. And then if I actually did this with a calculator, I'm just going to pull up Desmos. Oops. Here it is. So 46.13 minus, I already forgot what it was, 15 point something. Let me go back and look.
237.
15.237.
Yeah.
Yes.
Good job. Okay. So we get 30.893. That's pretty darn close, isn't it?
Yes. You could just round it up.
Yeah, exactly. So that's the usefulness of rounding. Let's try. What else did I like? So for division, like number 20, we have 54.63 divided by 4.7. Division is a little bit different because if I'm just multiplying or adding, then I can go to like maybe the nearest whole number or tens or something, whatever's easy. But for division, I specifically want to try to find numbers that divide nicely. Okay, so instead of like maybe, thinking rounding this to a specific place, I'm going to say to myself, well, 4.7 is close to 5, but it's also close to 6, and it's also not too far from 4. So I want to find a number that's close to this number, but also divides nicely into whatever I'm going to round this one to. And this one's not too bad because if I round this to the nearest whole number, what would I get? 54.63.
55.
That's right. 55. And then if I round this to its nearest whole number, I get 5, don't I?
Yeah.
So 55 divided by 5 is
10
11.
or 11, sorry.
11. Yeah.
I did my calculator. I would not
that?
know it. I wouldn't know off my head. I did my calculator.
Oh, okay. That's all right. Yeah, you're allowed calculators on exams and such too. Yeah, so that is really useful. And then sometimes though, like if I had, let's just change these numbers just a little bit. Let's see. Let's look at this. Okay, so if I just round these, then I would round 43.5 to 44. And I would round 6.7 to 7. And that 44 doesn't divide 7 easily. I still would have to use a calculator. But if I say to myself, well, let's see what number is close to this that is a multiple of 7, and I get 42.
Mhm.
So I can do 42 divided by 7, which is 6. And so that gives me a really nice idea. So division is the only one where we kind of play with the numbers a little bit and try to come up with something that divides evenly. And then we have some of these other problems. Are we there yet? Yeah. Okay. So you're going to be, here's one that's like I was talking about doing a division problem here. So we have a raise of $310,000 is going to be evenly distributed among 196 employees, professors. So again, we want to try to come up with numbers that are pretty easy to divide, right? 310,000 is pretty nice round number anyway. But if I round it to 300,000, and then I round this to 200, now I can just divide. Did you know fraction is just division? So I can write this as, this basically says 300,000 divided by 200. So I can just knock off zeros on top with zeros on the bottom, which gives me 3,000 over 2, which would give me 1,500 or so per professor. So a good estimate for that would be 1,500. What questions do I need to answer about that one?
I think that like makes sense.
Okay.
If it was like if it was like 140 something professors, like could you round down to 100 or like like a whole like
Or
120?
because 150 goes into 300 nicely, so I
Yeah.
would probably
Oh,
use
true, you can
150.
round up, yeah.
Yeah,
Okay.
great question. Yeah, I like to use something that's going to kind of be close and easy to divide. So you kind of play around with the numbers, and that just comes with practice.
Mhm.
The other type of problem that you will see in the homework is something like this number 38 here. So in this one, I have 10 people ordered phone charging cables. One of them was $4.95. That was the least expensive. One of them was $12.95. That was the most expensive. And then half of them paid $6.95 for their charging cable. And we want to estimate the total order. So you want to really pay attention to a couple of things. The most expensive, I'm going to write them all down over here. So the most expensive was $12.95. The least expensive was $4.95. And then we had half of them were $6.95. And we ordered, there were 10 in all ordered. So if you think about if all 10 people ordered one that cost $12.95, that would be $129.50. Yeah, just multiplying by 10.
Hmm.
So there's no way that this answer could be right, because that was the most expensive one. So the total has to be less than $129.50. So that's not a very good answer. Also, if they all paid $49.50, or I'm sorry, $4.95, the total would have been $49.50. So this probably isn't a good answer either. So now I have to pick between these other two answers. And what I'm going to do is I'm going to say, well, half of them paid $6.95, right? So let's assume if everybody paid $6.95, then $6.95 times 10 would give me $69.50. That's probably a pretty good estimate. And that answer's not there, but this one is pretty dang close, isn't it?
Mhm.
So this is the best estimate, right? I want the best estimate. All the others are not as good. What questions do we have about that one?
But do we have to like include like the other half though? That
Well, the other half, we know that the cheapest one was $4.95 and the most expensive one was $12.95. So we're just going to assume that they all paid the middle price and that the cheaper and more expensive ones balance each other out.
okay.
Does that make sense?
Like is it more so it's like estimating like you kind of like you can't base it off like your calculations because you don't know what the other half Like you don't
We-
know if like,
We know what half of them paid.
Yeah,
plus
but the other half, like we
yeah.
don't know.
We know what 7 of them paid. We don't know what the other 3 paid.
Hmm.
But
Yes.
because half of them paid this, that's the majority. We can assume that the price is going to be about 10 times this. Now, if we had had the most expensive one was like $1,000, then we would have to shoot higher, wouldn't we?
Yeah.
But because the lowest cost and the highest cost kind of average out to be about what the middle cost is, we can just assume they're all the middle cost.
Okay. Okay.
And
So like, are
that's
they
what,
saying like, oh, sorry.
no, go ahead.
Like, are they saying that like the other half could have ordered the 695 one too as well? Or,
So like we have, I'm going to just erase some of this over here. So let's just pretend we have, I'm going to write out. Okay, so I have one person that paid $4.95. And I have one person that paid $12.95. And then I have all these 5 people because half of them paid $6.95. Okay, so I don't know what these other 3 paid, but I know that it wasn't less than $4.95. And it wasn't more than $12.95. So I could just kind of, let's just assume that it's close to what these guys paid. Let's just say they all paid about $7 too. And then I can add all of these up and I'll get a number that's close to 75.
yeah, yeah. I got like 66, like 67.
Mm-hmm.
Unless I
And
missed
even
one,
if
but
even if we brought all these up to $12, we're still going to be,
yeah, closer to 75 than 100.
yeah.
Okay, that makes sense.
Mm-hmm. Yeah, that's one of the most challenging problems for people to kind of wrap their head around. It's like, but I don't
Yeah.
know. But we do have enough information because we know the lowest and the highest price. So that's what I had for today. But
Mhm.
as you're working through the homework, if you come across any questions that you're not sure how to do, give them a try, but you can also reach out either to me or if you're in someone else. If I'm not the professor for your section, you can also reach out to whoever is, but you can, I'm here too, so you can always ask me as well.
Okay. Thank you
Thank you for coming. Come next week too.
for having this.
Yeah. I hope to see you all next week.
Thank you.
Have a good day. Bye.
You too. Bye.